Are you scared of the sigma notation? I've heard this from a lot of students that they're terrified of how to read the sigma notation, how to make sense of anything to do with sigma notation. So, in today's video, I'm going to break it down in real easy steps and also solve some questions. Do enjoy the video. So, sigma, given by this symbol, which is an inverted W rotated in one side, is a Greek letter, and this is used to give summation or sum of a series. So let's take a closer look at how should we read this. So let's say I have the symbol sigma. Now I'm going to write from k is equal to 1 to n. So this defines your lower bound and this defines your upper bound. So I can write as simple as k, let this be our series. Then what this essentially means is from the values of k equal to 1 till n, it would be the sum of all the numbers. So 1, 2, 3, so on until k becomes equal to n. So your job is to just iteratively use the numbers between the lower bound and upper bound and keep increasing that by 1. And then instead of writing this entire series, you can write it in a really short form using the sigma notation. So let's look at another example. If I had a series which was defined as 1 plus 4 plus 9 plus 16 plus 25, if you observe, this is neither a geometric series nor an arithmetic progression series. So what we would do is we would see if there's any pattern associated with the numbers. So this clearly looks like 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So instead of always writing this huge series, what I can do is I can use the sigma notation. Now our series begins with 1 and ends with 5 square. So my values would be k is equal to 1 to 5, and I can just write this as k squared. So iteratively my values would be squared and added up, and this would be the sigma notation for this series. Now let's take a sigma notation and try to expand the series. So let's say k is equal to 1 to 6 2k. So the first thing I'm going to do is put the value of k as 1 into this 2k value. So 2 times 1 would be my first element. Second element would be 2 times 2. Like I said, we have to iteratively increase the value. So 2 times 2 plus 2 times 3 plus 2 times 4. Until where do we keep going on? We would keep going on till k becomes equal to 6. So 2 times 4 plus 2 times 5 plus 2 times 6. So the series is essentially 2 plus 4 plus 6 plus 8 plus 10 plus 12. And this was the expansion for this sigma notation. Now let's look at some properties of sigma notation. So the first property is that if I have a sigma notation which is represented as k is equal to 1 to n, ak plus bk. Suppose I have this, I can expand this and make them into two individual sigma notations because each of them could correspond to their individual series. And this comes in handy when you're given a really complicated sigma notation and you want to break it down into smaller series and figure out the solution for that. So this is your first property. And the second property is if your sigma notation is multiplied with there is a constant times the term, then you can take the constant outside your sigma notation. So this would become c times k from 1 to n a to the power k. Now let's use these properties to find the solution for some of our questions. So the first question is sigma k is equal to 1 to 6, we need to find the value of 11 minus 2k. So like I mentioned, first let's substitute the value. So one thing that you observe over here, the 11 would consistently keep repeating until 6 times. So we can either individually find the terms or split this up into two parts. So I'm going to find the individual terms. So my very first term would be 11 minus 2 plus 11 minus 2 times 2 plus 11 minus 2 times 3, and I will keep going on until 6. So 11 minus 2 times 4 plus 11 minus 2 times 5, and finally 11 minus 2 times 6. Now I'll just simplify these. So 11 minus 2 is 9 plus 11 minus 4 is 11 minus 4 is 7. Then we have 11 minus 6, which would be 5. 11 minus 8 would be 3. 11 minus 10 would be 1. And finally, 11 minus 12 would be negative 1. And then I can simplify the series. So negative 1 and 1 gets cancelled. 9 and 7 would be 16, and 521 plus 3 would be 24. So this would be the solution to this sigma notation. Let's take another question now. The next question is sigma k is equal to 1 to 5, 3k minus 5. So in the previous one, I didn't expand it first before simplifying. In this question, I'm going to use the properties. So I'm going to write this as k is equal to 1 to 5. First, I'm going to separate out my terms. So I can write it as 3k minus sigma k is equal to 1 to 5, 5. Now I can take the 3 outside as well. So this becomes sigma k is equal to 1 to 5k minus, now sigma 1 to 5k would just be repeating 5 times. So this would be 5 times 5, which would be 25. So this is 3 times 1 plus 2 plus 3 plus 4 plus 5. When we expand the sigma notation, minus 25, which is going to be 9, 10, 12, 15. 15 threes are 45. 45 minus 25. So your final answer would be 20. So this is how we go about solving sigma notation questions. If you found this video useful, do subscribe to my channel. And if there are any questions or topics you would like to see more videos on, hit the like button, comment your suggestions, and I would be more than happy to make videos on that. Thank you.